Hi, my name is Gretchen Bandoli. I'm an assistant professor of pediatrics at the University of California, San Diego, and my presentation is on using trajectory methods to identify sensitive periods during pregnancy. So you just heard from Christy Palmston about different types of trajectory methods, and now in my presentation, we're going to go through some specific examples using both k-means longitudinal as well as group-based trajectory methods with an application towards perinatal epidemiology. So the reason why Dr. Palmston and I really started kind of getting into looking at different ways to classify exposures over gestation is even though when you think about the course of a lifespan, the time in utero was such a short amount of time, but those 40 roughly 40 weeks in gestation are highly dynamic with with huge changes happening daily, weekly across gestation. And so depending on what outcome you're interested in, your exposure window may be very, very narrow. When we think about things like major structural malformations, the first 12 weeks are critical, but even within those malformations, we know that different weeks will close that critical window for when the structure has finished development and someone is no longer at risk to, for example, a teratogen of interest. However, outside of structural malformations, there are also other time-related factors that we need to think about when we're looking at different exposures across gestation. And importantly, we often don't know when the sensitive periods are or kind of when the periods of relevance are to the outcome that we're looking at. And so that's why we started looking for different methods that would be more precise in being able to show us the timing, the intensity, and the duration of exposure over gestation. And it's not only the changes that are happening to the fetus. Pregnancy is also a highly dynamic time for the mother as well. Her behavior may change from her previous behaviors before she recognized that she was pregnant, and those behaviors may continue to change across gestation. Specifically, the management of medications and other exposures is also highly variable, and this is something that Dr. Palmston and I have been looking into a lot, because often when a mother finds out that she's pregnant, she may choose to discontinue either a medication or an exposure that she's been taking. She may substitute something else. And then later in gestation, she may actually resume or change the dose, either due to fear of complications with the pregnancy or because of the physiologic changes in pregnancy to the woman necessitating a change in dose. So these issues are compounded by the fact that we have potentially short etiologically relevant windows. And as I mentioned earlier, we often don't understand those windows. It's challenging to estimate the timing of gestation, and there's also tremendous variability in the timing of recognition of pregnancy. So we know that often a lot of changes happen around when a woman recognizes that she's pregnant, but that timing of when that pregnancy recognition occurs is also highly variable from pregnancy to pregnancy, resulting in a lot of behavioral changes that kind of can span across multiple weeks or months of gestation when you're looking across a group of pregnancies. So I'm going to go through 3 specific examples of using longitudinal cluster analysis in pregnancy, and we're going to start by talking about alcohol exposure in utero. So this is some work that we did, and the kind of motivation for this work was, again, historically, we've tended to classify things like alcohol as a dichotomous variable, whether someone drank. We may look at within each trimester, was someone drinking, yes, no. Sometimes we would use a cumulative dose across gestation, but like Dr. Palmston showed in that heat map, you can get to the same cumulative dose in very, very different ways across gestation. And alcohol is one of those exposures that we often see overlapping with a pregnancy before the recognition of pregnancy, then dropping off fairly quickly upon pregnancy recognition in some, not all pregnancies. And then sometimes towards the 2nd or 3rd trimester, you may actually see a resumption of alcohol consumption. And so we wanted an exposure variable that was flexible to those different scenarios. One of the kind of upfront things that you have to do when you want to do longitudinal cluster analysis is getting everyone on the same time scale. And so you need a data set that has at least 2 time points. Otherwise, there's really no need to do trajectories. And then you need to kind of get it into almost a calendar form where everyone has a day 0 through a day, whatever you're looking at. So here we had a cohort of over 700 women who were enrolled in a prospective study based upon their alcohol use around the time of conception. And here we had reports from the visit 1 that happened sometime in the 1st or 2nd trimester of what the mother was drinking around the time of conception, when she actually recognized pregnancy. And then we had a report from what she was currently drinking in that first visit 1. And then we also had a visit 2. And so from that, where she updated her alcohol exposure information. So from that, we could essentially make a calendar where we took the visit 1 current drinking information and pushed that back to the time of recognition of pregnancy. She had told us how much she was drinking around conception. And so we could then push that forward to the time of recognition. And then we updated that information with the second pregnancy interview to tell us if alcohol consumption had changed. From there, that got everyone into kind of a standard calendar of the average drinks per day. And we then grouped those into weeks and performed longitudinal cluster analysis. This was done in R with KML. Some of the questions were asked about how you choose a number of trajectories. And as Dr. Palmson mentioned, there's really kind of no right answer. What we were looking for was to have enough people in the trajectories that we could do multivariable analysis. If you end up having, and you can think about that in the same way you would have your own exposure categories for any variable. But if you end up having to collapse down over a bunch of trajectories, you're kind of losing the benefit of doing those trajectories to begin with. But so out of ours, we had these 5 trajectories. And the way we kind of describe these are the women who had low or no use of alcohol in pregnancy. The women who started, these are absolute ounces per day, which 1 absolute ounce is equivalent to about 2 drinks. So here at 0.5, these are women who start having about a drink a day. And we had these divergence of trajectories where some women continued that in this low sustained group in blue, whereas some women had a pretty rapid discontinuation there in the low to moderate with reduction. We then had this moderate to high group who reduced alcohol early in pregnancy, and then this high, somewhat sustained group across gestation. And so when we look at the trajectories, what we were really interested in was particularly trying to exploit these 2 trajectories in the blue, which was the sustained trajectory, and the red that started off much higher, but dropped off. And so what you see is interesting is that we end up with this cross in the second trimester. So even though in the first trimester, this group in red actually had a lot more alcohol exposure to the offspring than the group in blue, once you get into the second trimester, we have a cross here where the fetus is now exposed to a higher level if they're in that blue trajectory than in the red. And you can see that here with the means that even though the overall pregnancy mean was essentially the same between the C and D trajectories, that while C started off lower at 0.42 versus a 0.62, they then crossed in the second trimester and then ended up at essentially the same place in the third trimester. And so we then took this and looked at our outcomes of interest. So we first looked at infant size at birth, looking at the weight, length, and head circumference. And what you see is that this group in blue, recall these are the ones who had more sustained, lower but sustained exposure, actually had lower weight and length at birth compared to the group in red, who started off with a higher exposure, but then dropped off earlier. These confidence intervals completely overlap. It was just interesting to see the different point estimates there between the 2 trajectories. We also looked at neurodevelopmental outcomes. This was measured with the Bailey at both 6 months here on the mental and psychomotor developmental indices, as well as at 12 months. And we saw this same thing that not in the mental development, but in all of the other scales at both 6 months and 12 months, this group who had that lower but sustained exposure tended to have slightly worse outcomes compared to the group who had the higher exposure with earlier pregnancy reduction. So we were interested in how would this look if we had just done a traditional analysis? So if we hadn't teased out that kind of nuance of the 2 exposures, would we still have been able to see this? So we just did a traditional exposure analysis where we took the cumulative dose over pregnancy and divided it up into no use, light use, which was less than 1.5 drinks per week, moderate use, and heavy use, and then reran these analyses. And this is how we kind of would have typically done an analysis like this. And what you can see when we compare it to the trajectories is that we still, in that kind of low group in green, which matches our low group up here, you still see essentially the same thing, that there's really no change in any of the Bailey scales. You still see that in that highest trajectory in blue, that maps on really well to the high use here, But what we lose is that nuance between the two groups where you had the continued low exposure and the high exposure that dropped off. Those, if we had done a traditional analysis, will just get collapsed into the same estimate. And so you'll essentially just collapse over those, losing that nuance of how different patterns and the timing of change of alcohol can affect the outcomes. And so another group has actually done very similar work to this in a completely different data set. This came out of the Safe Passage study looking at drinks per drinking day of alcohol across gestation. And this group used the group-based trajectory modeling, the parametric approach that's available in SAS, as opposed to our non-parametric approach that was that we used in R. And what was really interesting is that when you compare the trajectories that we had to the trajectories that they did, there was actually a lot of similarity between these. So again, these are different data sets, but their parametric approach also found this low trajectory. They found kind of a moderate trajectory that sustained use. They had these two moderate and high discontinuing trajectories, and then more of a high, somewhat sustained trajectory. So it was really interesting seeing that in a completely different data set with a different longitudinal modeling approach, we really saw very similar patterns of use emerge. And this group has not published on their neurodevelopmental outcomes, but it'll be really interesting to see if they see some of those same things there between these crossing curves on differential risk estimates with their outcomes of interest.